Well, hello everyone, and welcome back to the Tin Barn. I'm Pragmatic Lee, of course, and today I'm going to start a new project. I think it's going to be an interesting little project. Last year, for Christmas 2015, excuse me, I made my 7 nephews and great nephews and my son-in-law and grandson a little Christmas gift. 25 caliber cannon, fully functional, it fires. Like I say, I've got 7 nephews and great nephews, and then my son-in-law and son-in-law and grandson, and then I made myself 1 too, so that was 10 of those that I made last year. I made them on my little mini mill and mini lathe. Wasn't a whole lot of precision in them. It was a whole lot of drilling holes, little machining on the barrel just to dress it up a little bit, but most of it was just cutting and drilling holes and squaring up the pieces. Well, this year I decided to do something for my 3 brother-in-laws. I've got 1 sister and whose husband, and then my wife has 2 sisters and their husbands, so it's 3 brother-in-laws, and of course making 1 for myself as well. And what it is this clone, I guess you'd call it, of the Eagle 66 pump oil can. I'm going to be making 4 of these in the coming video. I think this will probably be a 2-part video. I'm making it out of aluminum base, tube, the pump housing inside, the cap, and the spout. All the accent pieces are made from brass. The tip on the spout, the trigger, basically again all the pieces. And they, just like the cannons, they're functional. They pump, and again we'll be making 4 of these. And in the video itself, what I'll be doing, these plans are available online, thehobbymachinist.com forum, but I'm going to be showing you the plans in the drawings as well. I'm going to put the video together in the order of the line items. There are 22 items in here. Some of them are purchased items, such as O-rings, springs, so forth. But the rest of them are machined items. And I'm going to put the video together in the order of these items. And just before each segment of the video, I will put about a 10-second snip of the page and the item itself that I'm working on. That's not necessarily the order, well, it's not at all the order that I made the pieces in. You'll also see in the video my collet chuck that I made extensive use of in this video, in this series. It's a 5C collet chuck for the lathe, and I haven't had an opportunity to make a back plate for it. So you'll see it mounted actually in my 4-jaw chuck. I'll mount the collet chuck in the 4-jaw chuck. Indicated in, it worked fine. It worked, as a matter of fact, it works so good. I'm not in a hurry right now to make the back plate for it. But enjoy the video. Like I say, it'll be 2 parts. At the end, we'll come back and we'll put the pieces together and assemble it for a finished oil can. Line item number 1 on our drawing is the base for the oil can. Drawings call for a piece of stock 0.735 thick by 3.1 inches in diameter. Going to load that in the collet, in the chuck, and to To bore out for the tube itself, I'm going to start with a 1/2 inch end mill, 9/16 end mill, just to give a good flat bottom to start with. I've got the tailstock DRO zeroed out now. Alright, we're going to start with our boring bar. I'm going to get a close zero from the DRO, and I'm going to bore this out to the diameter of the tube itself, which is approximately 2 inches. It's sold as 2-inch tube, but it will vary a little bit. I'm going to bore this out, and when I start getting to close to it, I'll bring you back. Alright, I'm getting very close to the diameter of our body now, and I'm having to remind myself that each time I make a turn, I'm taking off the diameter. So I'm going to take just a couple thousandths at a time on the dial and measure between each one. And that's a good tight fit. A little Loctite, and I won't have to concern at all about it leaking. I have my compound swung around to 35 degrees on my dial, and I'm going to just simply cut a bevel on this edge, or might call it a big chapper on there. Okay, I'm pretty well happy with that. So I'm going to turn it around now. I'll buff that up just a little bit. Matter of fact, while we're running, I like to put the lathe in reverse when I'm doing this, just so that the jaws are pulling away from me instead of pushing into my hand. I have our base flipped around now in the chuck, and just like on the top side of the base, I use the end mill to get us a flat bottom starting hole, and we're going to make a hole in here. This is a 1/4 inch deep, and remember from the top side was a 1/4 inch in, so that leaves about a 1/4 in the middle. But we're going to make this diameter here approximately 1 inch. Then we'll relieve it from the bottom of that hole to leave just a small border on the outside here to come in contact with the surface it sets on. All right, I'm going to get the compound set up now. Okay, I have the compound set up now, and we're going to bevel from the bottom of this hole to approximately 1/8 from the outside edge here. I'll move the carriage out of the way, then I'll get that buffed up, and this part should be finished. And there's our base. Line item number 2 is the body of the oil can. This is a piece of 2-inch. I've lightly got it clamped in the vise to keep from crushing the sides. I've moved in 1 inch and this I will drill these for 3/8. And since I'm going to have to be moving the column up and down, I'm going to move the table first to each location. That's 1 inch from the first hole. I'm going to be drilling this very slowly, and I'm going to drill it a 64th less than 3/8, and then actually go back and ream it for 3/8 just to have a better fit so I don't have a lot of ragged edges. One other quick comment about the body. When I sawed these off, my saw didn't cut them perfectly straight. I doubt there's very many saws that will cut them perfectly straight. But obviously I couldn't put this in the lathe chuck to try to face it off. Because simply clamping this in the jaws of the lathe would likely crush those sides in. So what I did was just take my square and place it on there and found any high spots, marked it with a pencil, then went to the vertical belt sander and just kept working those sides down. Did that on both ends until I got the end square. Line item number 3 is the cap. I'm starting with a piece of 2 1/4 inch diameter by 3/8 of an inch thick round stock. We're going to drill a 23/64 hole all the way through. Now we're going to bore that out to just a little over 2 inch, so it's an easy fit over our cap or over our body. So I'll get the boring bar set up, and I'll bring you back when we get close to having this bored out. We'll be boring it a depth of, let's see, 150 thousandths. I misspoke. Instead of 150 thousandths deep, that was 250 thousandths deep. So I'm going to keep boring this out until we're close to our 2 inch mark. All right, we're close now. We've got a few more thousandths to go. We want, for the cap itself, we'll want a loose fit, not a sloppy fit, but a loose fit. And that's just fine right there. It will have a screw through the top of it to hold it in place, and it will have an O-ring to seal it. to cut the internal O-ring groove. I'm not a whole lot on grinding tools, but I did grind this one, and we'll see how that works out. The plans call for 124 thousandths undercut in here for the O-ring. We're going to cut out, excuse me, I'm going to start with about 100 and then fit to the O-ring from there. I've got the DRO set. And need just a little more in the width. All we want is for this O-ring to lay in there. And it does. It's a good fit. Grab the deburring tool and polish up the edge, and there's our cap. The next piece I'm going to work on is what's called the top screw. It's line item number 4 in the drawing. I made one to begin with from aluminum as per the plans as far as the size. It called for this to be a 1/2 inch round. And after I got it done, I just don't like that smaller size. Plus I decided I would go with brass instead of aluminum as well. It has a shoulder on it and a 1032, get it in frame here, a 1032 socket, 1032 set screw, or grub screw as European friends like to call it. But I'm going to make this out of brass, and I'm going to make it 3/4 inch diameter. I'm going to knurl it with just my little knurling tool that came with the set of quick change tool post tools. We'll see how that works out. I've never done very much knurling and haven't done any brass, so we're going to see how this works out. Well, that's not looking too bad at all. As a matter of fact, it's looking pretty good. I'm going to make a couple of passes on that, and then I'll bring you back. The piece is knurled now, and so we'll start working on turning our shoulder on the end, drilling and tapping for the 1032, and then parting it off. Alright, I have these 1032 set screws left over from another job, which works super in this. I'll carry that over to the sander, and sand off that little tit left on the end of there, and then polish that up. Line item number 5 is the valve body. We're making this out of 2-inch wide by 1/2 inch thick aluminum flat bar. We're going to turn this down. I've got it indicated in the forejaw, and we're going to turn this down to the diameter for the size tubing that I'm using for the body. The plans, if you happen to be following along in the plans call for 2-inch brass tubing with a 50 thousandths wall thickness. So that's 2 inches minus 50 thousandths on each side leaves 1.9. It calls for this body to be 1.8. So that means there's a difference of 100 thousandths between this valve body and the tubing itself. My tubing is 2 inches, but it has 63 thousandths for each side. So that leaves 1.874. And if I stay with that constant 100 thousandths difference, that means I need to shoot for a diameter of 1.774 for this. Now, in making this interrupted cut, and of course there's 4 interruptions to begin with, the 4 corners, then there'll be 2. It was throw chips up in the air, really all over everything. So using something I saw on Phil's projects again the other day, and I asked him about it and he explained it to me. I have a left-handed turning tool in the holder right here. Let me get it out where you can see it. It's a left-handed turning tool, and it's in there upside down. I've got the lathe in reverse, and of course the feed in reverse. And by doing that, that is making the chips go down for the most part. It's slinging one every once in a while, but for the most part the chips are going down. So I'm going to cut this down and to our 1.774. Okay, this is this piece that I have in here now is going to make 2 of these valve bodies. I'm going to turn this in, then we'll turn it around and do the other end. Each end of this will have the will be milled. Be drilled and tapped for a holding screw to hold the lid on. But since there's not much mill work that has to be done on the milling machine, I'm going to wait until we get over there to drill and tap it. That way I can leave this set up. So I'm going to continue this process, and I'll bring you back when we get to the toward the finish. We have 18 more thousandths to go. So I'll dial that in and make this final cut. .773. I believe I can deal with that. Okay, I'll get this out and show you what it looks like. And as I've said in the introduction, I'm using aluminum for this with brass just for the accents. So yeah, let's see. So there's about 100 thousandths clearance, and that's what the plan's called for in there. Now what I'll do is turn these around and do the other end of it, and then we'll go over to the mill and start drilling our necessary holes. All the valve bodies have been turned on the lathe now, and we've got them over here at the mill. I've got the center located. We're going to drill and tap in this first step a 1032 3/8 of an inch deep in the top of each piece. This needs to be 3/8 of an inch deep, so I'll zero out my Z-axis. Now we'll use the bottom tap and snug it just a little bit. Alright, I'll continue that process on the remainder of the valves. I have a work stop set up now, and I have .315 located from the edge here. We're going to drill a 5/32 through hole. This side, the plans also call for a tapped 1/4-28 3/8 deep, and it calls for a 7/32 drill bit, but my Starrett chart shows a number 3 tap drill, so that's what we're going to use here. And that's zero out the Z-axis, and we want to go down 0.375. Now I need a 1/4-28 tap. I'm going to start out with the tapered tap just to get the thread started, and then we'll go with the bottom tap. Alright, I'm going to continue this process for the other 3, and then I'll bring you back when I get ready to work with the other side of this. Alright, the next step is to flip this over and do the other side. I've put away all the taps and drills I had for the first side so I don't get anything mixed up. And on this bottom side, we want to, the same through hole, we want to drill and tap that for a 3/8 24. Plans call for a 5/16 drill bit, but a 21/64 is much closer to a 3/8 24. It actually, 3/8 24 is actually a letter Q bit. I do not have a Q. This is within 6/1000ths of it, so 4/1000ths of it. So that's what we're going to use. And it says, zero out to Z, it says drill to a depth of 710. And just like before, we're going to start it out with a tapered tap just to get the thread started. And the plans say drill this, or I'm sorry, tap this to a depth of 0.5. So I'll be watching the DRO instead of watching for the tap slip. Got the DRO set to 0. Now I'll continue this process on the remainder of the pieces for all the oil cans. To finish up our valve body, we need 2 more holes in the side. Note, I do have our through hole down here on the bottom now, so we're going to drill a hole for the spout and a hole for the trigger. The first one is a 1/2 inch in from the top, and the other will be 1 inch from that. This is a 5/32 hole that will be drilled through to this hole down here. Okay, that's broken into the 7/32 hole. That was a through hole. This hole is a 1/2 inch deep. And as before, we'll use the taper tap to start and then finish it out with a bottom tap. Now we're going to move over 1 inch. This hole, all right, the plans say ream it 0.3125, which is 5/16. I'm going to drill this out first with a 19/64 and then run the reamer through it. And this again drills out to the depth of this bottom hole. We want to come into that. Remember, on the bottom side down here, let me get one of the other ones. Remember, it's a much bigger hole down there that we'll be drilling through too. Now we want to ring this out to 5/16. This is the hole that our trigger will be in. And of course an O-ring will be riding in this. Now the top, well, this will be drilled or tapped, tapped for 3/824 by, I think there's a misprint on the drawings. It says by 13/8 deep. That should be 3/8 deep. Okay, we should be complete now with our valve body. Just a little cleanup and we'll be finished with these parts.